Hello, welcome to The Intersect, where academia, Department of Defense, and industry meet. I'm Matthew Butkovic, and I'm joined today with my colleague, Tom Longstaff. Hello, Tom. Greetings.
Matt, how you doing?
Great. How are you?
I am fantastic.
It's great to be back together in a physical space.
It really is.
In a safe way.
It really is. It's been a long time since we've been able to do this, and although it's going to feel a little strange for a while, I am looking so forward to being able to doing these kinds of interactions again. Just incredibly looking forward to it.
Well, thanks for joining us today. The topic today is the broadest topic I think we've introduced here at Intersect, which is working at the SEI, working for CERT, given my role. And so, Tom, I just wanted to start with maybe if you would give us a description of the mission of the SEI. Why does the SEI exist?
Sure. So at the Software Engineering Institute, we were created in 1984 really to answer the problem, how do we make software an engineering discipline? How do we bring software development into the engineering discipline world? In the early 80s, it was very much a cottage industry. And so that was the creation of the SEI. Today, we've taken that original mission and really sort of rounded it out so that we not only take software as an engineering discipline, but cybersecurity into an engineering discipline, and most recently AI into an engineering discipline, to really understand how best to do those three areas, not in a stovepiped way, but instead understanding how cyber and software really go together, how AI and cyber go together, how AI and software go together. So at the Institute, we really try to hire people and to find people who are curious and really interested in understanding this intersection between software, cyber, and AI, basically for the future of the Department of Defense, the U.S. government, and the world.
Thanks, Tom. So some interesting elements of your description. So it's about the convergence of things.
Absolutely.
So this convergence of software engineering and cyber and AI, and born out of a need to apply a rigor or an engineering discipline to the software question and then to the cyber question. Now, Tom, you've been with the SEI for quite some time.
Yes.
I was wondering if you could share with us your experiences working at the SEI, maybe the path that brought you to the SEI.
Sure. So, truth in advertising, I've been to the SEI twice. So I started in 1992, one of the earliest hires into CERT. CERT started in 1988. Right after the Morris worm, Robert Morris Jr. had created one of the first really popular worms on what was then the ARPANET. And it took out most of the ARPANET during that time, which was largely academic, a little bit of Department of Defense that was in there. DARPA at the time, was ARPA, said, we don't know how to manage an incident like this. We need to find someplace who can do a coordination of this. So the CERT Coordination Center was born. About a year or two into CERT, really standing up operations, I was actually hired from Lawrence Livermore National Lab, fresh PhD, to start up a new research group at CERT, primarily to take all this data that was being collected and do something with it. Find out what we could do in terms of adding science to the cybersecurity. So I started up the first research center at CERT, and after that we started up many other centers having to do with analysis and training and, Matt, more to your point, into risk and sort of understanding risk and sort of the better ways that way. So I was there until 2007. And then in 2007 I went to Johns Hopkins for about 10 years. And I've just recently come back a little more than 2.5 years ago as the Chief Technology Officer.
Now, Tom, I don't know if are you a native Pittsburgher?
I am not. It's hard to say I'm a native anything.
Okay.
So, I was born in Maine, but raised mostly in Florida. I've lived in California. I've lived in New York. I've lived in Boston. But my son was raised in Pittsburgh.
I see.
And so really Pittsburgh, since that's where he calls home, that's more where I call home.
Well, one of the reasons I asked, Tom, is I am a native Pittsburgher, and a point of pride for me is certainly Carnegie Mellon.
Yes.
But moreover, working in cyber, I think we legitimately claim that we are the birthplace, not maybe perhaps it's a stretch to say for cyber, but certainly cybersecurity. We had a very prominent role, as you described, in 1988, being the nation's first federal cyber equity in a sense.
Yeah.
And certainly on the software engineering side, we were the first to look at these challenges. So the reason I mention that is, point of pride as a Pittsburgher is that the SEI is headquartered here in Pittsburgh, attached as part of Carnegie Mellon University, and doing great work for the Department of Defense. So another example of that intercept, right?
Absolutely.
and you've intersected with the SEI a few times. Can you describe the changes you've seen in the need for cybersecurity or the way that we go about researching these topics?
Sure, absolutely. So I'll start with a shorter answer, and we can sort of dig into this because it's actually a long and interesting story that kind of goes through this. But let's start by going back to the beginning of CERT. When CERT was created, there were a number of response teams started up right about the same time. I think arguably CERT was the first. I was actually in the Department of Energy's team, which was also stood up in 1988. Within a week,
I didn't know that.
when CERT was stood up, I was their tech director, on the Department of Energy team at the time. In the early days of CERT, understand there was a large body of security professionals who dealt primarily with mainframe systems and systems that really were time-sharing. How do you do security in time-sharing systems? How do you do security in very closed systems? After the Morris worm, there was a new type of cybersecurity engineer created. This was the engineer saying, what if we have an open network that anybody could join? Anybody. And what if in this network not everybody was a good player? What do we do? How does that differ from what you could do in a closed network? And CERT became key in defining what that kind of cybersecurity was. It was a completely different way of looking at cybersecurity in the early days. In fact, there were a lot of conflicts early because those cybersecurity engineers, like I was in 1992, were young bucks and young men and women who really challenged the traditional thinking with computer security and information security. And we challenged it in a way that was often not very popular from the more senior colleagues of the time. But really, we were there at the beginning and made the prediction that there would be waves of different kinds of architectures, different ways that we would engineer these systems. And CERT has had to adapt to those waves each time. So we started with an open network. How do we understand how to mitigate vulnerabilities? How do we understand how to patch systems? Slight anecdote, early 1990s, there were no such thing as free security patches. There were not. All of the companies at the time had a business model that you paid for security patches.
So paying to fix the defects in the product you've already purchased.
Absolutely. So you can imagine how many people actually fixed their defects. Very few. CERT was really key in getting companies to change their business model, starting with like Sun Microsystems and Digital Equipment Corporation and Wang Computing and all of these various places that eventually changed their model so that security patches could be free and would come out and update the systems. That was a primary role of CERT in the early days. Then firewalls were invented. Bill Cheswick and Steve Bellevin really made popular the idea of creating this new infrastructure of a firewalled set of systems. CERT's research changed. What we did change, we adapted to this new architecture on the internet and really said, how do we configure firewalls to make the kinds of security mitigations that we want to do?
So Tom, just as an aside, for the audience, it might be a bit strange to think of a time before firewalls.
Yes.
The idea that you didn't screen, regulate, or somehow control access.
That's correct.
So,
That's correct.
And I think it speaks to the longevity and the foundational contribution that CERT has made. I'm sorry to interrupt. Please continue.
No. And I'm going to basically, at each point, the researchers at CERT, the people who were doing this work at CERT, had to adapt to these new architectures. And there were about every 5 or 6 years a new kind of architectural change. And it happens all the way through to today. I mean, we went from firewall systems to integrity-based systems to VPN-based systems to whole series of different sort of deperimeterization. And that goes to today with cloud-based computing and finally into zero trust and zero trust architectures. We're still undergoing massive shifts in the way that we architect cybersecurity. So CERT needs to be on the forefront. What research do we need to do to make sure that we can take the best advantage of the security architectures and adapt to the changing threat, the changing risk, and the changing mitigation strategies that are now popular within the system?
Thanks, Tom. And you mentioned risk. If I may, I just had a thought to offer the audience. So, all of the things we've just discussed, the architectural decisions, the technology stack, those are fundamentally, in a sense, subordinate to risk decisions. Mm-hmm. So, as things change, I'd also then point out that some of these absolutely core decisions about risk attitude, risk tolerance, risk appetite, those are enduring. Now, the way that you apply that, and that's the heart of the work that I'm doing here at CERT primarily, which is how do you then determine a rigorous way to measure, quantify, and make those risk decisions? So I want the audience to understand, it's one of the reasons I really like working at the SEI and at CERT is that we have this blend of things that are going to be with us for a very long time conceptually, but we also adapt to these rapid changes in technologies and getting on the forefront to anticipate the next wave.
So, I talked a lot about the changes in architecture over the years in terms of how we adapted. Why don't you go into a little bit into changes of the way we thought about risk since you started the SEI?
Yeah, certainly.
And talk a little bit about your history there.
Thanks, Tom. So I came to the SEI from industry. I was working in manufacturing, before that banking. Why did I come to the SEI? To answer a question folks may have, since one of the reasons that we're talking today is to explain to people opportunities here at the SEI. The SEI, to me, provides a sort of intellectual freedom I wasn't finding in industry. I wanted to do cyber, but I wanted to do cyber in a way that was broad-based and help the community in ways that you really can't do working for any company, no matter, or most companies, given the circumstances. So one of the things that really appealed to me was that it wasn't just about technology. It was about the interplay between technology, people, processes, a very strong lineage here in process, right, given CMMI and our software engineering background. So it was the first time I saw cybersecurity expressed in a way that was equivalent to other engineering disciplines. And that really appealed to me. How has risk changed? We've gone from needing to make very tactical decisions about risk, right? So when everything is under your control, within your own four walls, to give you an example, it's easy to shut off access to the outside world. It's easy to make decisions that affect a circumscribed group of users. Now that computing is ubiquitous, connectivity is perpetual, a very different situation. So you mentioned the cloud. The cloud is a good example of this. We're now doing things at arm's length, which means doing things in a way that are different than making those risk decisions internally. The appetite for risk, it waxes and wanes. There's an upside to risk. That's an important thing to know. The upside of technology risk is your agility and ability to do things like acquisitions, to introduce new tech. So it's the struggle between the defensive posture of risk management and seeing the upside of risk. So that's one of the keys there, Tom. I'd also say that one of the things I'm very proud of, and I think CERT's played a critical role in this, going from managing by sort of fear and uncertainty, right? When we do executive education or we talk to boards, if the cybersecurity role, the CISO or the CIO, wants to be part of that conversation, they need to express risk in a way that's comparable with the other functions, right? The CFO doesn't say, bad things could happen, they're really complicated, so I can't explain them to you. So I think we've been instrumental in quantifying risk. How will risk management change? I think about emerging tech, and I was hoping, Tom, we could speak a little to quantum and AI. We've seen these waves of technological change. I think some are simply evolution, some are truly a watershed moment. I think quantum is arguably more revolutionary than simply evolutionary, potentially. But as these technologies emerge, we must apply the same risk reasoning, but understand implications that may be vague, if that makes sense, right? So right now, I don't think you and I can say in 20 years what the true implications of quantum will be, yet organizations have to make decisions about investments and their research strategy.
So I may not be able to say exactly what it's going to be like in 20 years, but I can guarantee that we're going to have different architectural approaches to understanding how to mitigate risk in a quantum-based world, and in a world where we have other advanced computing models, and in a world where AI dominates as the primary way that data is actually used in, basically that's being created. Think about how much data we're actually creating every day. This number of sensors that are out there, the number of sensors that are just collecting data everywhere, are bringing all of this data back in. Our historical use of this data has been to crawl through it and search it. AI changes that entire mindset. I'm actually one of those that is very positive on the future of AI and the future of quantum, for that matter. I believe that we're going to be able to use the advances we have in machine learning and things beyond machine learning into more general AI to really help us get a better handle on securing systems and to get a better handle even on the ethical use of security within our infrastructures. And sort of back to risk, Today, I think you would agree that risk is primarily a human-based activity.
Absolutely.
It really is one of these that you can put a lot of mathematics behind it. You can have a lot of quantification with regard to risk. But at the end of the day, it's a human really calling the shots in terms of risk appetite. I believe there is a shift coming, which is going to allow us to use data in a better set of recommendation systems that allow us to not completely turn over the risk decisions to the system, but to help humans better make reasoned decisions based on the data in risk. And that changes the model. I think it changes the game in terms of what we're doing.
That is a really interesting point, Tom. So I think about my drive in this morning. So my car is making risk decisions. What I mean by that is the computers in my car are taking in data, there's sensors and cameras, and they're making risk decisions. So I would argue this is permeating other parts of our lives, and we'll see it in cyber sort of properly soon. So we know that AI offers many advantages when it comes to analyzing data, making decisions. I think a corollary is we very well may see, and I would argue we are already seeing, the rise of synthetic adversaries. So AI attacking, not just being used to defend. Can you maybe comment on that, Tom, and
Sure.
where you see that going?
Somewhat, right? I mean, we obviously at the SEI are very concerned with adversarial models in a whole variety of angles on this. And the use of AI by adversaries and as adversaries is a tremendous concern. It changes the model of what we need to do for mitigation strategies. Traditional mitigations that we've used in terms of network both analysis and restrictions, or system analysis and restrictions, don't map nearly as well to an AI-based world. So new kinds of mitigation strategies have to be created, verified, and then propagated and around so that we really get those into the critical systems that are there. I mean, obviously there's going to be a rapid change in what the adversaries do, but this is not new.
Right.
And then this is the point I want to make. AI is a new type of technology and does introduce new skills, but we have done this over and over and over again at CERT. Every time the game has changed, we've had to change the research and the engineering to come up with it. That's why the most important people to find to come and work for us are people like you who are curious and want to apply both science and engineering to the problems that we have and that we have not yet discovered.
Yeah, Tom, I liked your description. You mentioned the people that we recruit to work at the SEI. I'd like to spend a little time talking about those skills. So I encourage everyone that's interested in the audience today, we have open positions. Please do visit our website. There's a number of roles. But Tom, if we could maybe explore the skills that we think are going to be important in the future, and the types of roles we're recruiting for now. So I think, as you described, certainly we're in another sort of step change phase in cyber. What do you think the skills are that we'll need in 5 years for folks that are maybe? So obviously it's college graduation season. If you're studying now, if you're in university now, and you aspire to work at an FFRDC and hopefully the SEI or work in this field, sort of what skills do you think will be important in 4 or 5 years?
So, I think the most important skills that we've identified in the past that have been the most productive at CERT, the best people that we've ever hired, have been people that bring together a number of skills that are not normally brought together. So today, I would say, core mathematics, especially statistical mathematics, in combination with electrical and computer engineering, are two that come together in a way that are really important to us. AI research, in a way of really understanding how AI research is going to move us into an engineering discipline. So in other words, not just about the algorithms, but about the application of AI into unique domains. Those are the kinds of backgrounds that are really good for us. In the cybersecurity area in particular, we're looking for creative people that have really gone beyond the traditional cybersecurity types of mitigations and really come out with new, interesting approaches to cybersecurity. Folks that have contributed to open source, people that have contributed to different ways of approaching the way these security systems are going to work. Those are really interesting to us. And I'll say one more thing. One of the places that we're pivoting is How is cybersecurity going to change in a future world of virtual collaboration? How is cybersecurity going to change when we're no longer staring at each other through 27-inch panes of glass, but instead have virtual presence where we're all basically beginning to blend our physical and our cyber personas together? Having people that really understand are at the forefront of understanding where that is going to happen and how it's going to happen. And I'm talking about people in the gaming industry, people who are really understanding virtual reality, people who are really looking innovatively at those uses of the new technologies. That's going to be a place that we have to be and have to move into within the SEI.
Yeah, I absolutely agree, Tom. And I think you've hit the nail on the head. We need people that have a strong curiosity. This is also a highly interdisciplinary effort, as you described. So if you're a cybersecurity practitioner now, and you have an appetite to do new things and learn new things and acquire new skills, I think it's a great place to be. Our mission is very specific. Right? It was described this way to when we first started the SEI, that it's a very self-actualizing organization. So not only is the obligation to do really good work and advance the state of the practice, it's also then to amplify that message, to introduce that to the community. We're not simply just gold on have we done something, but rather what's the impact of the something, and have we articulated that value then broadly to our stakeholders.
So I'll add one more thing to that that's really seriously important. We have always been a scientific-based organization. We use scientific evidence in the creation of our advice, in the creation of how we propagate solutions. We want to be absolutely grounded in fundamental science, in the way that we can have reproducible scientific experiments, the way that we curate data that we actually come in. We don't like to do things ad hoc, where they can't be repeated, and then just go out with opinions. That is one of the places we try to differentiate, and it's our relationship with Carnegie Mellon University that helps us stay intellectually honest with regard to the science behind what we're doing in cybersecurity. So we need folks who not only have that curiosity and that sort of background and understanding how to do multidisciplinary, but who have a real respect for the scientific process and the use of scientific method in the creation of our results.
That is an excellent point, Tom. And is your role as CTO, right? This is something that's front of mind for you.
Absolutely.
And I would also add this, that that means you're willing to admit when you're wrong.
It means you must and try to be wrong.
Exactly.
No, more than that. You try to be wrong. You try to stick your neck out far enough that you don't know if that solution is going to be right or not until you collect the evidence.
Yeah. So being wrong isn't failure in our context, and that's really important. That is quite frankly a difference with working in most of industry. If you're not in a research capacity.
Right.
So I think I hope we painted the picture of kind of what we do and why we do it and the people we're looking for. I think it's also important to note that the association with campus isn't simply on our business card, right? That we are active participants in the university community, and I would argue beyond just this university. We are part of this ecosystem of people that are focused on these topics. Maybe speak to the reach that we have sort of broadly outside of CMU?
Sure. Well, first of all, I should say that we are broadcasting right now from CMU campus. We are on the campus proper. This studio is actually part of where we are within the boundaries of CMU. So we are broadcasting today from the CMU campus, and our association with CMU is both broad and deep across many of the departments. But beyond CMU, we have a lot of roles in the academic community where we typically chair or on the program committee for many conferences and many journals where we're editors or associate editors on the journals. We have a big footprint in IEEE. We're a member of our CERT staff as the president of IEEE. We really believe in community engagement in this kind of way. It is the best way for us to be out there. And beyond that, engagement with the private sector so that we understand where the problems are coming and where the future is that's being invented by the private sector and how that's going to change the research that we need to do. Finally, of course, there's our connection with the Defense Department. We are here as a DoD federally funded research and development center. DoD is center stage always for the work that we do and for the benefit of our soldiers and airmen and sailors that are out there really putting their lives at risk every day. And those are the places that we want to make sure we have the most impact.
That's great, Tom. That's, I think, an absolutely key distinction, which is we are advancing the state of the practice, we're advancing the state of the art, and we're doing this all to ensure that the U.S. Department of Defense remains highly capable, more capable than adversaries. And at the end of the day, I need to remind myself of this sometimes, that we are doing things that, in a very practical, literal, demonstrable sense, make the warfighter more capable.
Yes.
And that is different than the roles I had in industry.
We absolutely do. And in fact, that's actually a key thing to understand for people who want to come and work for the SEI. We work for the benefit of the Department of Defense. We do. We enable the Department of Defense. We help to protect the Department of Defense. We increase their capability. We increase basically the cost structure, the trustworthiness, the reliability of software throughout DoD. We do the future of software within DoD. We look to the future to say, what is software going to be like in the future at DoD? How is that going to change the nature of the fight that we're actually going to do? Coming to the SEI means you are a part of that. It means you are a part of that structure helping to enable this. And I think it's a terrific mission. It attracted me here twice. And I couldn't be prouder of the work that we do.
Well, the same, right? I'm proud to be part of this organization. I'm proud to have colleagues that are on the forefront of these topics. And there is a meaning and an impact that you can have here based on this mission that is different than other places.
Absolutely.
It's also at a personal level, as I mentioned, the intellectual freedom. If tomorrow Tom and I decide that there's a pressing need for something, we're not only encouraged, but I would argue gold to bring that forward.
Yeah.
And then to lead that effort, to articulate what needs to be done, and assemble the resources then to tackle that challenge, which is very different than the more constrained or circumscribed roles I had in industry. Again, it's a great place to be. Industry is a great place to be. The DoD is a great place to be. Academia is a great place to be. I really like that we're at this interesting intersection of the Venn diagram here at the SEI.
Yeah, we really are. And, it's not that we don't have oversight. We do. And we do get approvals for our work. And it does have to be meaningful. We have governance activities. We're in the middle of our governance season right now in terms of creating and making sure that our strategy for FY22 is on track and sort of moving forward. But that gives us a tremendous amount of latitude in terms of the kinds of things that we research and the ability for us to really move forward in that world.
Well, Tom, we're approaching the top of the hour. I certainly appreciate your insights, and it's great to be back in the studio here. Look forward, as you mentioned, the governance activities and where CERT is headed and the SEI is headed broadly. I hope we come back in the future. We can have a talk like this again. But in closing, I would like to encourage the audience, if you have an interest in the SEI and CERT, please do visit our website and please do reach out. Right there.
Come work with us. And if you're not actually looking for a new position, come and partner with us.
Yes.
We partner with a lot of folks. We really try to work with the best that's out there. We're not a tremendously huge organization. We must partner and leverage everywhere that we possibly can. Please work with us.
Thank you. Thanks, Tom.
All right. Thank you, Matt.